Now it's time to talk about how we name covalent compounds. So as previously kind of hinted at, covalent compounds can get a lot more complicated than ionic compounds. So one important thing to note, we are only going to learn to name binary covalent compounds. What that means is that there's only going to be two elements in the compound. And so they're going to overall, these binary covalent compounds are going to overall have similar format, similar kind of names to the ionics, because you think the ionics have cation, anion, so two types of objects. And then in the covalent compounds, we're similarly going to have, because they're binary, two types of atoms. So it's going to follow the same idea kind of overall. So one of the implications of that is our covalent compound names are going to look kind of similar to the ionic compound names. And so the general idea we start with is that we give the name of the first element. We don't change the ending or anything like that. And when we say first element, this would just be in the order of the molecular formula. If we're given a molecular formula, we just say, what's the first element in that formula? We write out that name. Then for the second element, we can see we use that same IDE ending to change to the root. So for example, H is the hydrogen, and then F is fluorine, and this isn't an anion, this is a covalent compound, but we still call it fluoride. Okay. Similarly, when we have Br is bromine, and then Cl becomes chloride. Okay. I is iodine, it's first, so we don't change the ending. F is second, so that becomes, again, fluoride. One thing to note, I don't expect you to be able to come up with this order. There is a rhyme and reason to this, but I do expect you to maintain it. So if you have HF, that is hydrogen fluoride. If you have hydrogen fluoride, it should stay HF. Those orders should be maintained when you go back and forth between formula and name. With covalent compounds, we don't have the crossover method that was available to ionic compounds, where you could just be given the ions and figure out what the formula was. And so when we're dealing with covalent compounds, we need to include additional information. If there is more than one atom of an element in the molecule, we add a prefix based off that number. So here is our interpretation of those prefixes. Each number of atoms corresponds to a particular prefix. And so prefix does mean we put it in front. So we can see here that the reason why we need this is that in the case of ionic or covalent compounds, say between phosphorus and chlorine, you can form two different compounds. So you can have P is the phosphorus, and we can see again P is phosphorus. Okay, that's great. But then we have Cl 5. So that 5 becomes penta. And we just add it on top of the chloride. And we can see that penta is right here, is always means 5. Similarly, switch it up, we have this 3 right here. That is trichloride. So this is a little bit different than we had with the ionic compounds, where you're just trying to figure out what the charge is. You don't need to do any fancy things. There's no switchbacks or anything like that. This is just phosphorus trichloride. You literally just say how many chlorines are in there. PCl5, pentachloride, because there's a 5 on that chlorine. And so that's really what you're looking to get after. I guess I should connect to those. 3 is tri up there. And so we're just that always going back and forth, always that sort of translation between these ideas. One thing you'll note is that phosphorus did not get a mono prefix. Mono does mean one. Generally, we don't use mono very much, and we never use it when it's the front atom. So the one time we really do use mono is when it's the second atom, and really only when it's oxygen. So we can see here that CO, the C is the carbon, but we don't call it monocarbon because it's first. So carbon, and then the O is oxygen, and that does get the mono. Really, the only time you really ever use mono as a prefix is when it's with oxygen, because it's carbon monoxide. Really that. We would never use it in the front though. If oxygen is the first atom, you would never say monooxygen or monoxygen. It's only monoxide, right? That IDE has to be there when you're using mono. Mono is never used in the front. You only use mono on the second and really only with oxygen. There are some other fringe cases, but we're not going to worry about those. I'm not going to test you on that kind of stuff. I'm not going to try to trick you. There is one other kind of caveat when you're using these prefixes, and that's the idea that you'll note, so for example, on mono, it ends with O, and then that would be oxygen starts with O, but you can see here that that O is cut out. It's not monooxide, it's just monoxide. Similarly, tetra becomes, it's not tetraoxide, it's just tetroxide. So it's slightly different. The reason why I'm pointing this out is that these prefixes that end in A's and O's, so basically everything except di and tri, you do drop those when you have a double vowel. You drop the prefix vowel. I'm not going to test you on these. If you make that kind of mistake, I would count that correct. But sapling will be ticky-tacky about this kind of stuff. So on some of the namings on sapling, you will have issues like that. And also on Blackboard, it may mark you wrong. I would go back and correct that. But that's sort of, that is technically the incorrect spelling. So if that happens on sapling, that could be an issue, that it's a double vowel thing. I wouldn't worry too much about it, but that is technically how we, a part of the rules for naming. It's quite in the weeds, though. I won't worry too much about it. All right, let's get some practice. Naming binary covalent compounds. Name the following covalent compounds: SF6, P4O10, and HCl. When we're looking at naming covalent compounds, the first question we always want to ask is, well, what's that first element? How many are there? Because now we need prefixes. This is what's different between covalent and ionic. Then what's the second element? How many are there? There's no process of determining charge. There's no polyatomics to remember. It's just literally looking up the atom name on the periodic table, potentially changing the prefix, changing the suffix on the second one, and adding prefixes. So, for example, SF6, I have 1 sulfur and 6 fluorines. Okay. So sulfur is in the front. It doesn't get its name changed, right? Just the full name. Because it's 1 in the front, no mono or anything like that. And then the 6 just is hexa. So this becomes sulfur hexafluoride. P4O10, that's 4 P's and 10 O's. Okay. In this case, neither has 1, so both atom types are going to need a prefix. So it does become a bit of a mouthful, but the 4 is tetra. You'll note phosphorus, we just keep the entire name. We don't have to change the ending. And then we have 10 becomes, that's deca, but like decade. It's the same, 10 years, dec in this case. And then the O is then the oxide. It does need to get its name changed because it is the second atom in this case. So a bit more complicated, tetraphosphorus decoxide, but one of the reasons why it's more complicated, there's a lot more parts in there, because you're conveying more information. You're not just conveying that there's phosphorus and oxygen in there, but you're conveying the number of each of them, 4 phosphoruses and the 10 oxygens. HCl, that's 1 hydrogen and 1 chlorine. So in the name on this one, we're not really going to use monos anywhere, so it's just hydrogen chloride. We really don't need to be using those monos. We certainly never would on hydrogen. You might see it on chloride really sometimes, people being really ticky-tack, but really that's only with oxygen that we would use it. So just hydrogen chloride. It's kind of in the same way that we don't write the ones in the formula, right? We didn't write the 1 subscripts. You don't put mono as a prefix. So those are binary covalent compounds. There's a lot of covalent compounds that aren't binary, and so they can't have names like that. And even some that are binary covalent have what we call common names that are much more commonly used or kind of just historical names. So things like HCl would be technically hydrogen chloride. In some contexts, especially when it's in water, we call it hydrochloric acid. NH3, nitrogen trihydride, is more commonly known as ammonia. N2H4 is in rocket fuel. That's called hydrazine. H2O is kind of the standard case. We would call that water. Dihydrogen monoxide would be technically correct, but also would never be referred to as that. Water's just so common. And so on all of these, there are two common names that you need to know. Ammonia for NH3 and water for H2O. Those are the only ones that I'm going to use, and when I would expect you to know those common names. When you break binary covalence, so for example, C6H12O6, that's just called glucose. There are systematic names for those, but these molecules become so complex so fast that the systematic name is so convoluted and so confusing that it's easier just to memorize what glucose is as opposed to memorizing all the rules for how you would name a complicated molecule like that. So as they get bigger, the common names just have stuck around because the system to name them has to be so complicated that it's just difficult to even think about or use. There's so many rules to memorize. All right, no participation questions here. One more video to go. Looking for more questions on participation 6.5 due Friday the 5th. See you in that final video. Bye-bye.